Alright, welcome back. We're doing lesson 9.2, but part 2. Now we're actually going to do some calculus involving polar graphs and points. So let's take a look at number 15 here, where I ask you now to find an equation of a tangent line. Oh, you've seen this question before, but now we're going to apply it to polar graphs. The graph of r equals 2 bracket 1 minus sine theta, which of course if I expand that out, that can just be 2 minus 2 sine theta. And it's at the particular point 2 comma 0. Now this is 2 comma 0 as a rectangular coordinate point 2 comma 0. So remember, the idea of a tangent line is just y equals mx plus b, right? So we need to find what m is, and m stands for the slope, and the slope is just dy dx. But unfortunately in this case we've got a polar curve, so how do we figure out dy dx? I hope you remember back to our parametric talk in lesson 9.1. Remember the idea of the parametric derivative? Remember? Something like this. dy dx equals to dy over dt divided by dx over dt. Remember? Well, we don't have dy dt and all that kind of stuff. What we do have, though, is theta. So how do we apply here? Well, we will just replace the t with theta. So dy d theta all over dx d theta. And that's how you can find dy dx. So what's dx d theta? Well, we have to go back to our original ideas of what is defined as x, and it's equal to r cos theta. So in this case, r is our function 2 minus 2 sine theta. Going to multiply this by cosine theta, and that's equal to x. So therefore the derivative dx d theta, I see product rule. A prime b plus b prime a. Okay, so a prime, that would be negative 2 cos theta. A prime b, which is cos theta, plus b prime, so negative sine theta, the derivative cos, and a 2 minus 2 sine theta. Yikes! I guess we could try to simplify that if you wish. This is negative 2 cos squared theta. We'll distribute here minus 2 sine theta plus 2 sine squared theta. There you have it, dx d theta. Yikes! That's just one partial bit, right? We need dy d theta as well, so I'll go over here and do the same thing. Y equals to r sine theta. So if I make the substitution for r once again, that's 2 minus 2 sine theta times sine theta. Yikes! We can use, well, let's actually distribute this one. It's nicer, right? 2 sine theta minus 2 sine squared theta. That's so much nicer for y. Makes our derivative so much easier. Forget product rule. Derivative 2 sine theta is 2 cos theta. And then this is a square, right? So 2 sine theta, chain rule, cos theta. Nice. That's dy d theta. So in terms of our slope, which is dy over dx, I need to have now the dy d theta on the top, which is 2 cos theta minus 4 sine theta cos theta. That's just from here. And then I'll take this one and stick it down here. Negative 2 cos squared theta minus 2 sine theta plus 2 sine squared theta. And that now, my friends, is the slope of the tangent at any particular point. Now the question is, I want the slope at the point 2 comma 0. So at 2 comma 0, what is my actual angle theta? So this is now thinking back. Okay, here's 2 comma 0 right here. What is theta? Now we gotta look back at our function. And I hope you can see that theta equals to 0, because sine of 0 is 0. 1 minus 0 is 1. 1 times 2 is 2. So the point here, x comma y, also connects to the fact that theta equals to 0. Which means that for my dy dx, I want it evaluated at theta equals to 0. So plug in 0 into that expression. Let's see what we get. Cos 0 is just 1, so 2 times 1 is 2. Sine 0 is nothing, so forget that. We have a negative 2. Forget the signs. And so I think what you'll see is that this equals to negative 1. And so our tangent line equation, y equals mx plus b, so y equals to negative 1x plus b. We can plug in 2 comma 0 to find out b. So y is 0, x is 2, so I believe b just equals to 2. Y equals to negative 1x plus 2. Done. Okay. So, a lot of work, but you know, we're trying to review all these calculus principles you've learned before. Equation of the line, slope, using product rule to calculate parts of it, and using the parametric equation. So, really fitting a whole bunch of pieces together. Okay. How about 16 now? Find the points where the graph of r equals 2 minus 2 cos theta has a horizontal tangent. So, horizontal tangents. If you want a graph, and I've given you the grid here for x and y, you can go ahead and just sketch out the graph, up to you. If you don't remember what this one looked like, you can turn to the previous page. This has the form of a limacon, I believe. If I plug in cosine 0, that's equal to 1, then 0, so I think it starts there. And I'll just roughly draw this out for you right now. You don't really need to do this yourself if you don't want to, but it looks like this. Okay? I'm asking for where do you think the horizontal tangents will be. You can probably see it right away on the graph, like somewhere here and somewhere here. Like, okay, find out where then. So how do you find horizontal tangents? Think about what a horizontal tangent means. It's the derivative equals to 0. And remember the idea of a derivative here. That's dy dx equaling 0. But remember dy dx is defined as what? It's dy d theta divided by dx d theta. So in this case, which one of these derivatives do I want to be equal to 0? Well, it's the numerator, so dy d theta equals to 0. So in essence, if I ask you for horizontal tangents, then I'm saying, oops, wrong color. If I'm asking for horizontal tangents, I'm saying, come on, find out where dy d theta equals to 0. And to do that, I'll use the y equation, that's r sine theta. And I'll replace r with our equation, 2 minus 2 cos theta times sine theta. Up to you how you want to do this, product rule or whatnot. I'll just expand this out. That's just how I want to do it today. It's up to you really which you prefer. It doesn't matter to me. But now you're ready to take the derivative with respect to theta. The derivative of 2 sine theta is just 2 cos theta. And over here, hello product rule. It's up to you how you want to do this. Just go ahead and do it. Derivative of sine is cosine. And then I'll just change it to a plus sign because that would be 2 sine theta with another sine theta. And lo and behold, this just becomes minus 2 cos squared theta. And then here you have 2 sine squared theta. Our goal here is to solve or make it equal to 0. So solving is hard when you have two different trig functions. I hope you remember how we can rewrite sine in terms of cos. And if you thought the Pythagorean identity of 1 minus cos squared, I'm so happy you still remember stuff from pre-calculus 12. Yay! If you didn't like trig, sorry. And if we do some simplifying, what do we get here? This is the 2 You have a negative 2 cos theta. Wow, lots of 2's here. Yuck. Well, I see negative 4 cos squared theta plus 2 cos theta plus 2. I heard someone say, factor! Okay, I will factor. Woo! What is this factor 2? All this factoring becomes what? So you get 2 cos theta plus 1 cos theta minus 1. And don't forget you want this to equal to 0. Someone check my factoring, please. I think I'm right. And if you do this, notice you get here that cos theta equals to negative 1.5. And also cos theta equals to 1. Let's do the easy one first. Cos theta equals to 1, so that means theta equals to 0. That's kind of hard because that's this point here at the origin, so I don't think so. But from here we can solve, and if we solve the inverse cos of negative 1/2, good old special angles, cosine half, I think the reference angle is pi over 3. Cosine is negative in which quadrants? All students take calculus. Quadrants 2 and 3, so how about pi minus pi over 3, or 2 pi over 3, and then pi plus pi over 3, or 4 pi over 3. And that seems to make sense to me. Because looking at my graph now, 2 pi over 3 is about here, that angle, so that makes sense. And then 4 pi over 3 is this angle over here, and that makes sense. What's the actual r value though? Because you want to find the radius. Well, you can plug that back in. If you plug that back into here, you will find that I believe r is equal to 3. So find the points. The points are 3, 2 pi over 3, and also 3, 4 pi over 3. And these are points in the polar form. So if you want me to be more specific, I'll say r, theta equals 2. There you go. Okay. Hey, just a quick thought. What if I change this word horizontal to vertical? What would you then do instead? Well, for a vertical tangent, then that means it has to be undefined, so that means your denominator has to equal 0. And yes, if you're thinking that means dx d theta equals 0, you are correct. If you're thinking that's what you want me to do right now, you are incorrect. You don't need to do that. But just letting you know, that's how you find the vertical tangents. Okay? Alright, last tangent type question. Can you find tangent lines at a pole? So this one says find the equation of the line tangent to r equals 4 sine 3 theta at the pole. I gave you a little graph here to sketch out as well, so can you do that first? That's a review from last day's work. Doing a quick sketch, figuring out what this is. You should see that this is a rose petal curve. Okay, I'll quickly graph it out. You should be able to do it yourself too. Let me change. Yeah, we're good. So here we go. Woo! 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 Okay. This first one actually should be a little bit bigger. Woo! You get the idea. In any case, there are tangent lines at the poles, right here in the middle. You should be able to find some tangent lines. Well, gotta figure out what the angle is equal to at the pole, so perhaps at the pole that means r equals 0. So let's just plug that into here and solve. So 0 equals to 4 sine 3 theta. Divide both sides by 4, that's still 0 equals sine 3 theta. And so what's theta? Well, what's 0 for sine? The inverse sine of 0. That, of course, is what, 0, pi, 2 pi, and so on. So that's all equal to 3 theta. So theta is equal to 0 over 3, that's 0. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and also 6 pi over 3, which is just 2 pi. So guess what? You have to find tangent lines at all these points. 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, 4 pi over 3. Have some fun. Well, go ahead, please. And to find the derivative, you should be able to do it. X equals r cos theta. R is 4 sine 3 theta cos theta. Take the derivative, dx d theta. Deep breath. Product rule. And chain rule. Put the negative in front, okay? Do the same thing for y. Y equals 4 sine theta. That's 4 sine 3 theta times sine theta. Dy d theta. Product rule again. Yikes. Extra factor of 3. And just to let you know, that over that equals to dy dx. So can I just write down dy dx equals to blah 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 in yellow divided by blah 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 in blue. Okay? I don't want to write it again. And now I'll leave this up to you as an exercise to evaluate and figure out the equations of the tangent lines. There are, by the way, 3. You'll see that they actually repeat. So I'll leave this as an exercise to you, and when you come to class, you have to give me the answer, and then I'll know you've actually done your work by watching this video. Alright, see you in class with the answer.